In question 30, we're told that a runner and a cyclist are having a race, and we're told that the course that they are traversing on includes a flat section which is 1 kilometre, a muddy section which is 1.5 kilometres, an uphill section which is 500 metres, and finally a downhill section of 1 kilometre. And then we're told that the specific speeds that they achieve on each section of the course is as follows. So we can see that there's a runner and a cyclist which are having a race. In the flat, the cyclist is much faster. However, in the mud and the uphill, the runner is faster. However, in the downhill, again, the cyclist is 5 times faster. We're then asked to work out of our options A through E, which graph represents who leads during the race and by how much. So let's have a look at what these graphs look like. They have the following axis, where we have the lead on the x-axis, cyclist up top, runner at the bottom, so the cyclist lead goes up to 8 minutes, and same with the runner. And we have distance on the x-axis for the different parts of the course. So the first thing that we'll need from our graph to make sure that it's correct and reflects what's going on in this information is to make sure that the breakdown of the various sections is represented in the graphs. So we have a 1 kilometre section, a 1.5 kilometre section, a 500 metre section, and a 1 kilometre section. So that means we can draw out some lines just to give a sense of where we are. We should have a line here, this representing the first section on the flat. This 1.5 kilometre section reflecting what's happening on the mud. Then we have a 1 kilometre section on the, we have a 500 metre section on the uphill. And then we have a final 1 kilometre section on the downhill. So we have our 4 different parts of the course, and immediately looking through our answers, we can see that option E must be incorrect, since it has a different arrangement of the graph, such that the second course appears to end at 2 kilometres rather than at 2.5 kilometres. So we can say E is incorrect, we can rule that out, and now we can get into what the information is telling us about the graph, what it will actually look like beyond the superficial. So we know that in the flat section, the first section, the cyclist is going 5 times faster and therefore will take the lead. Now we don't even need to get into specifics of how the kilometres an hour relate to the actual distances and do the whole speed equals distance over time thing. All we need to do in this question is to work out the rough shape, and that allows us to do a process of elimination without any calculation. So we can say, in rough terms, the cyclist must take the lead since it's going 5 times faster, and we can see that we have our first uptick in the lead for the cyclist. Now this rules out option A and D, which don't show this uptick, so you can bear that in mind. Then we're going to have a section where in the muddy section where the runner is going faster, and this is the longest section, so perhaps the runner can build up a lead here, so it would look a bit like this. Moving on to our third section, which is the uphill. The runner is going even at a greater ratio faster than the cyclist, so 3/2 as opposed to 4/3, so the line should be even more steep in favour of the runner. So we should have something like this. We should have a sloping upward line for the faster cyclist on the downhill section, so it would look a bit like that. So this is the basic breakdown, so we can rule out options A and D because they show a downtick at this section. We can rule out option C because it shows an uptick in this section for the cyclist in spite of the fact that the cyclist is going slower in the uphill section. And we can say that our answer must be option B because it conforms to all the information given and has this shape here. So we have our answer.